Hello friends, welcome to Engineering Funda family. This is my first video of antenna and wave propagation video lecture series, and in this video I'll explain you radiation patterns of antenna. In general, there are three types of radiation patterns with antenna. First one is there regarding isotropic antenna, second one is there regarding directional antenna, and third one is there regarding omnidirectional antenna. Let us start this video with first agenda, that is radiation pattern of isotropic antenna. See, isotropic antenna is also known as point source. So from isotropic antenna, equal radiation will happen in all direction. So if I say at origin, at the center, we have isotropic antenna, then equal radiation that will happen in all directions. So radiation pattern will be sphere over here, where if you measure radiation intensity at distance r, then at distance r, radiation intensity will be equal, right? So here radiation pattern, that is sphere over here, means equally it radiates in all direction, right? So if you measure gain of isotropic antenna in any direction, then gain will be same in all direction, right? The reason is it is radiating equally in all the directions. So if you measure gain at any point, if you measure gain over here, if you measure gain over here, then that will be equal in all the direction, right? Isotropic antenna has only single lobe in its radiation. So first of all, you need to understand what is lobe. See, lobe is a region of radiation pattern containing the power or exhibiting field strength. So lobe is a region which contains radiation power. Here with isotropic antenna, radiation is equal in all the direction. So radiation pattern is sphere over here, means only single lobe is there, right? Now I'll explain you radiation pattern of directional antenna. See, there are many directional antennas that we use it in our real life, like parabolic dish antenna, that is directional antenna, horn antenna, that is also directional antenna, like Yagi-Uda antenna, that is also directional antenna. So directional antenna radiates more towards major lobe. Let me draw it and I'll explain you step by step. See here, if I say directional antenna is there at origin, and let us say major lobe is there towards y-axis. So here I am plotting major lobe, you see. So it is containing major power or major radiation intensity of field strength, right? So this is major lobe. So major lobe is having highest radiation over here, and with directional antenna you will be observing we also have side lobes. Let me draw it first. See, here we have side lobes. By black color I'm drawing it. So these are side lobes, right? And directional antenna also have back lobe. See, back lobe, that is opposite to major lobe, right? So here opposite to major lobe, that is back lobe over here, right? See, you need to understand few definitions. Major lobe, that contains major radiation power, and other than major lobe are minor lobes. Here if you observe, this is major lobe, right? Other than major lobes are side lobes and back lobe. So minor lobes are a combination of side lobes and back lobe, right? Back lobe, that is opposite to major lobe, right? And other than major lobe and back lobe will be side lobes, but minor lobes, that is a combination of side lobes and back lobe, right? So that is how few definitions are there that you need to understand. So directional antenna that radiates maximum towards major lobe, right? So highest gain that will be there in major lobe over here, right? And towards side lobes and back lobe, gain will be very less, right? Now I'll explain you third radiation pattern, that is omnidirectional antenna. See, in omnidirectional antenna you will be observing radiation is happening in plane. Let me consider some scenarios. As if I say this is y-axis, here we have x-axis, and towards you we have z-axis, right? So if I say on plane of XZ plane, right, radiation is happening, then radiation will be happening in this plane, which is there on XZ plane, right? And towards Y-axis, radiation will be minimum. So here you can observe, see, this is Y-axis. If I say radiation is happening in XZ plane, then it will be looking like this, you see. And to understand this radiation, let me take cross section over here. So if you take cross section, it will be appearing like this, you see. Right. So this is cross section that we are taking. So here you can say one thing, see, radiation that is happening in XZ plane, in which minimum radiation that will happen towards Y-axis over here, right? So as if omnidirectional antenna is having radiation in XY plane, then minimum radiation will be there towards Z-axis, right? That is how things are there. See, omnidirectional antenna radiates in a plane. Radiation plane may be XY, YZ or XZ plane. So major lobe will be there in radiation plane. Here major lobe that will be there in radiation plane, right? And it may have minor lobes as well. Let me show it to you how minor lobes can be there. See, here there may be minor lobes like this, right? Here may be minor lobes like this, right? Which is containing less power over here. See, in omnidirectional antenna, we don't have back lobe. Why don't we have back lobe over here? The reason is here major lobe is having plane over here. So there is no back lobe. The reason is back lobe that is opposite to major lobe, right? Here major lobe is how? Major lobe is there in plane. That's why there is no back lobe with omnidirectional antenna, right? So here there are a few basic things that you need to understand. What is lobe and how definitions are there, right? See, minor lobe that is other than major lobe. So here we have major lobe, right? And major lobe is having maximum power. So other than major lobe, we have minor lobes, right? And in omnidirectional antenna, major lobe is there in plane. That's why we don't have any back lobe over here. While in directional antenna, you will be observing all categories of lobes. This is major lobe and we have side lobes even, and back lobe that is opposite to major lobe, right? So that is how basic definitions are there. In next video, I'll explain you all the parameters of radiation pattern that will gives you more clarity regarding how radiation pattern can be understood. See, these are the radiation pattern that I have shown you regarding so many different categories of antenna. Here I'm not explaining you antennas. Here I'm explaining you how radiation patterns are there, right? In future coming videos, I'll explain you antennas even, in which you will be having further clarity regarding how radiation happens with given antenna. Still, if anything that you would like to share, please note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.